Ladies and gentlemen, my name is Mr. Do and science is my business. You are welcome to Mr. Do's Science World, and today we're going to talk about organic chemistry. Let's begin by knowing what organic chemistry is all about. Organic chemistry is a branch of chemistry which deals with the study of carbon and its compounds. Now let's look at what we call organic molecules. An organic molecule is molecules that contains only carbon atoms. So carbon has a valence electron of 4, which means that the outermost shell has 4 electrons, and for this reason a carbon can form 4 bonds, thereby forming many compounds with other elements. These elements this compound that will be formed from carbon will be named according to the structure or how the carbons are formed. For example, a carbon can form what we call a straight chain carbon. It can form what we call a side, a branch, or a substituent chain, and then they can form what we call a ring structure. These are the different types of structures which the carbon atom can form. Carbon can form bonds with elements such as oxygen and hydrogens. And when they are formed bonds with oxygen and hydrogens, it can be in this form or that form. Now let's look at the different types of the carbon compounds that we can have. We can have carbon compounds such as alkanes, alkenes, alkynes, haloalkanes, alcohols, carboxylic acid, esters, ketones, and aldehydes. These are the different organic molecules that we are going to look at. When you look at the first 4, which is the alkanes, alkenes, alkynes, and the haloalkanes, they have a common name, and the name for that is referred to as hydrocarbons. What is a hydrocarbon? A hydrocarbon is organic molecule which contains carbon and hydrogen atoms only. Now let's look at this and see. These carbon and hydrogen atoms that are formed can either be a double bond, a single bond, or a triple bond. And this gives us 2 names that we're going to talk about. And these 2 names are what we call a saturated hydrocarbon and unsaturated hydrocarbons. Now let's look at the definition of saturated hydrocarbon. A saturated hydrocarbon is a hydrocarbon that has a single bond within the carbon atoms. So let's take, for example, if I have a carbon and another carbon, the bond that will exist between these carbon atoms is a single bond. The bond between these 2 carbon atoms is a single bond, therefore we say that it is what? It is a saturated hydrocarbon. Unsaturated hydrocarbon is a hydrocarbon that contains multiple bonds between the carbon atoms. So we can either have it being a double bond or a triple bond between the carbon atoms. For example, if I have a carbon and another carbon atom, and we have a double bond between this carbon atom in this way, we call the unsaturated hydrocarbon. And if it can either be a double or triple bond, so we can also have something like this here, where there is a triple bond between the carbon atoms. So in this case as well, but remember that the carbon, each of them have to have what? 4 bonds. So 1, 2, 3, 4, 1, 2, 3, 4. So because this is a double bond, we say it is what? Unsaturated. Now let's look at different types of hydrocarbons that we have. The first hydrocarbon that we are going to look at is what we refer to as alkanes. So let's look at alkanes. An alkane is a saturated hydrocarbon. That is, any hydrocarbon that has only a single bond between the carbon atom is referred to as what? Is referred to as what? An alkane. Now, it is an alkane. It has a family name. And the family name, which means that all the alkanes are going to have one common family name. And that common family name is what referred to as the what? The alkanes. Which means each of them must begin with what? Must begin with a certain name and must end with a certain name. What it is ending with is what referred to as the suffix. And what it begins with is what referred to as the prefix. So let's look at the suffix for alkanes. The suffix for alkanes are ANE. So it means that all alkanes must end with ANE. Alkanes are low they have a low reactivity, which means that their reactivity is what? Is very low. They are unable to react very well. They are saturated. They have a general formula that will let you know that these are alkanes, and the general formula is CnH2n plus 2. CnH2n plus 2. Now let's look at the prefix. All alkanes have prefix, that is, they have a name that begins with. We said the suffix is what? Ane. That is what it ends with. If an alkane has one carbon atom, we call it met. If it has two carbon atoms, we say it is eth. If it has three carbon atoms, we say it is prop. If it has four carbon atoms, then we say it is but. If it has 5 carbon atoms, we say it is pent. There are 6, we say it is hex. If it is 7, we say it is hept. If it is 8, then we say it is oct. Now let's look at it and see. So if it has one carbon atom, we said the prefix is met and the suffix is ane. So it becomes what? Methane. If it is 2, it becomes what? Ethane. If it is 3, propane. If it is 4, butane. If it is 5, pentane. If it is 6, hexane. 7, heptane. 8, octane. These are the ways to name the what? The alkane. And I said the name alkane is the family name for a particular hydrocarbon. It's a family name for a particular hydrocarbon. In organic molecules, all family names are referred to as homologous series. Homologous series. So this alkane is the what? A homologous series for a particular what? Hydrocarbon. Okay, if you remember earlier, I said to you that organic molecules can either be a straight chain, a branch chain, or a ring structure. All that we looked at earlier about the alkane is a straight chain. Let's now look at a branch chain, where we're going to have a side or a substituent. So if there is a side or a substituent, we refer to that side as the alkyl group. Alkyl group. In this alkyl group, it means that each of them must end with the I. And that means that if it has one carbon atom, then we say that it is methyl. So like one carbon atom, remember we said if it is one, the prefix is met. So now we are adding the suffix I. So it becomes what? Methyl. If it is two, we are saying that it is eth. And remember, I'm going to add the suffix, so it becomes what? Ethyl. Right. So that same way is what is going to follow. If it is 4, it becomes what? If it is 3, then we are going to have what? Propyl. Now, this is the chain. So let's look at a typical example of the chain. If I have a carbon atom like this is saturated, and this is a straight chain. If I have any carbon atom attached here, like this makes it to become what? A branched or a side or a substituent. What is the substituent? The substituent is this, or the side or the branched is this one. And because it is one carbon atom, it becomes what? Methyl. If it is two carbon atoms, then we're going to have something like this, where we have this, and let's say this is here, and I have C2H5. So if I have C2H5, the C2H5 becomes the what? The substituent. And if that is the substituent or the branch, this will become what? Ethyl, because there are two carbon atoms. So it becomes what? Ethyl. Alright. That is how to know the difference between a branched chain and a straight what? Chain. Hydrocarbon. Okay, so let's look at the IUPAC rules for naming alkane or the alkane nomenclatures. The first thing that we have to look at whenever that we are naming the alkanes is that we have to consider and find the longest continuous carbon chain. So whenever you are given, you just have to look at the longest chain that you have in the carbon atom, and then you name that according to the organic molecule. 2, identify and name the groups attached to this chain. Then 3, you will number the chain consecutively starting at the end nearest a substituent group. The 4th thing you have to do, designate the location of each substituent group by an appropriate number and name. 5, assemble the name, listing groups in alphabetical order. This implies that the prefixes di, tri, tetra used to designate several groups of the same kind are not considered when you are arranging them alphabetically. Okay, let's look at examples of alkanes and how to make use of the rules in determining the names of the alkanes. Let's take, for example, we have a structure that looks like this. I know this is not familiar with some of you in countries like West Africa and in South Africa, but if you move on to first year in the university, you'll be familiar with this kind of structures, and I'm going to take you through this structure for you to understand. Okay, if you have a structure like this, and you look at this side, it means that there is a carbon atom here, 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 and there is a carbon atom here. So if I look at this is going to give me 1, 2, 3, 4, 5 carbon atoms. This in simple terms can be translated as something like this. 1, 2, 3, 4, and then we can have the 5. So there are 5 carbon atoms. So when we look at this, we are having a straight chain carbon atom. And this straight chain carbon atom, if you want to name it, the first thing or the first rule we said is to know the longest parent chain. To know the longest parent chain, we can see that there is 1, 2, 3, 4, 5 carbon atoms. So the longest carbon atom that we have there are 5 of them. Here 1, 2, 3, 4, 5. And because there are 5 of them, it simply implies that we are going to have the name, because it is 5, and that's going to give us what? Pent. And remember we said all alkanes have the family names ending with what? A. So we're going to end it with what? A-N-E. And because there are 5 carbon atoms, makes it pent, and the family names, which is the suffix, must end with what? In. Therefore, we are having what we refer to as what? Pentane. And this pentane, look at this. Very important in organic chemistry. If we draw the structure like this, we don't need to put the hydrogen atoms. We can name it simple as it is, as pentane. But if we write it this way, then we need to put the what? The carbon atoms. So let's look at it. I'm going to complete the bond. Remember we said carbon have 4 valence electrons, which means that it is what? It is a catenation. It can form 4 bonds. So if it can form 4 bonds, this is 1, 2, 3, 4. So we can put a hydrogen here, a hydrogen here, hydrogen, 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 in that order, and this completes the structure. And I know this is what most of you are familiar with, but this is the same as the structure that we have here. So that when you see something like this, it simply implies this, which is what? Pentane. Let's look at something. We want to connect it with the formula. We said the general formula for alkanes is CnH2n plus 2. So let's look at it and see if this commensurates with this. CnH2n plus 2. So let's look at it and see. How many C's do we have? 1, 2, 3, 4, 5. So that means that in place of n, we are going to put what? 5. So therefore, this becomes what? 5. And if we say 2 times 5, that gives you what? That will give you 2 times 5 plus 2. And that means that it is what? C5H. This is 2 times 5 is 10 plus 2 is what? 12. So let's check and see if we are having 12 hydrogen atoms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That makes it what? Correct. And then we get to know that this belongs to a family known as what? Alkanes. Let's continue with naming of the alkanes and see. Let's look at example number 2 and see something from number 2, example number 2, and see something from there. Example number 2 is a situation where we can have something like this. Okay, and then we have something like this and like this. So let's look at it. I have these, and from this diagram that I have there, I am having something like it here. So, first one we did was a straight chain hydrocarbon. But this time around we are dealing with what? We're dealing with a side or a subsequent, or what we call a branch chain. So let's look. This is the branch chain. So I'm going to circle the side for you, because remember I said to you there's a carbon atom here, 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 and carbon atom here. So I said to you earlier, I made mention of what we call the alkyl group, and that is the alkyl group. And I said if you have the alkyl group, the alkyl groups are the substituents that are found within the what? The alkanes, as what? As a side or a branch or a substituent. So let's look at it and see. If I have this and I try to find, the first thing is to find the longest continuous chain. So let's see. If I name this 1, 2, 3, 4, 5, 6, and naming this as 1, 2, 3, 4, 5, and naming, say, 2 here, 3 and 4. We want the longest continuous chain. If I name it from here to here, I am having 5 carbon atoms. If I name from here to here, I am having 4 carbon atoms. But if I name from here to here, I am having 6 carbon atoms. The longest, this is 4, this is 5, and this is 6. So the longest is what? Is 6. Which means that the parent chain is 6. And if it is 6, remember we said 6 carbon atom means what? Hexane. So now this becomes hexane. I have a hexane, but that is not the name of this structure. Because look at it, we have 1, 2, 3, 4, 5, and 6. There is something here, and that is the what? It's a substituent. I am going to draw this structure in the common one that everybody knows, and that is 1, 2, there is 3. This one here becomes this. I'm going to, okay, let me use different color for this and make good life very easy for you. So 1, 2, and we have this here. We have that, making this 4, and then we have 5 and we have 6. Okay, so I take off this and use a different color for us to understand exactly what we have. 1, 2, 3, 4, 5, 6, because we said the longest chain is 6, which means hexane, so 6 of them. The bond, this must take 4, there is 1 here, so this must be 3. There is 2 here, 2 complete it. Now there is 3 here, 1 complete that. There is 2 here, and we have that completing it. Now, I want to put the hydrogens there. So I put a hydrogen atom, hydrogen, hydrogen, hydrogen there in that order, and then tell you something here. Let's look at this. Okay. Good. Check this here. We are having 1 carbon atom here, which means that the carbon atom is on the 1, 2, 3, and there is another carbon atom. So therefore, 1, 2, 3, I take off this and I put what? A carbon atom. If I put a carbon atom here, that simply implies there is 1 bond here, so there should be extra 3 more bonds, 1, 2, 3, which means that there are 3 hydrogen atoms that must be attached to this. So I'm going to put here H3. There are 3 hydrogen atoms that are attached there. Once we have 3 hydrogen atoms, this becomes what we refer to as a substituent or a branch, which I have here. There are 6 of them. 1, 2, 3, 4, 5, 6. Once we have 6 of them, what does it mean? Hexane. But this is what? 3. It belongs to the what? The alkyl group. The alkyl group. And if it belongs to the alkyl group, it simply implies that we have what? 1 of them, which means it is what? Methyl. Methyl. Because there's 1 C, so it is what? Methyl. But this methyl is attached to what carbon number? Very important. So we name that 1, 2, 3, 4, 5, 6. I know somebody is asking the question, why not numbering it from this direction? Okay, I'm going to number it from that direction, and then we look at something. I number it, and then we will have 1, 2, 3, 4, 5, and 6. The important thing in chemistry, which we need to take note of, is that, now let's see. I'm going to name this based on this. Now you understand the structure and know it means this. So look at it. If I decide to name this based on the numbering from this direction, I'm going to have 1, 2, 3, 4, 5, 6. Right? So if there are 6 of them, then it's going to be what? Hexane. And this is attached to carbon number 3. So I'm going to have 3. What? What is there is what? The methyl. So it is 3 methyl. And the name is what? Hexane. So 3 methyl hexane. If I decide to name it from here, let's look at this. We have 1, 2, 3, 4. So that becomes what? 4 methyl hexane. Now the question is, which is the correct one? Is it 3 methyl hexane or 4 methyl hexane? The correct thing is 3 methyl hexane. Why? The why is because whenever we are naming the organic molecules, the substituents have to take the lowest numbering. And the lowest numbering here, we can see that 3 is less than 4. Therefore, the lowest numbering is 3. And that gives the name 3 methyl hexane. Another thing we need to explain here is, check it and see. I have 3 and I'm using dash methyl hexane. Whenever you are naming organic molecules, between the numbers you use a comma to separate numbers. Let's say we have 2 and 3 where there is substituent. That means that there is a substituent attached to carbon number 2 and carbon number 3. I will say 2, 3. But if I want to name a substituent, then we bring a number and the name. We use what? A hyphen to represent what? To differentiate between a number and the what? The name. Another thing is that if I am here within this name, I need to name it together. So I don't have to separate these two and say methyl and there is a gap before the hexane. No. We leave it and bring them together. So this becomes what? 3 methyl hexane. Okay, let's look at example number 3. Okay, let's look at example number 4. Look at this example number 4. I'm going to add substituents to that and then we do the naming by understanding the rules. So let's look at this. There is a substituent here and there is a substituent here. When I have anything like this, the question would be, how many carbon atoms do we have? Well, I can say there is 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5 carbon, 6 carbon, 7, 8, and there is none. Does that mean it is no name? No. The answer is no, because that is not the longest continuous chain. The chain is not continuous. We can name from here to here, come back here, go there, come here, this way and that. The only way we can name this and make it look continuous is to say 1. Okay, let me use a different color and make this simple. 1, 2, 3, 4, 5, 6, and 7. So if I have 7 here, then what can I say? 7 simply means that the parent chain is what? Is heptane, because it is what? 7. So heptane. But now there is a substituent here and there is a substituent here. Let me number it again and call this 1, 2, 3, 4, 5, 6, and 7. I'm going to name them from this side to here, and I will name it from here to here. Then we explain which is the correct one to use. So let's look at it. If I look at it from the left to the right, I'm going to see something like 1, 2, 3, 4, 5, 6, 7. So it is heptane. I know that's the longest continuous chain, which is the parent chain. But now let's look at the substituent. There is a substituent at carbon number 2 and a substituent at carbon number 3. But each of them is just one carbon, means that there is only what? 3 hydrogen atoms here. Which makes this what? A metal. And this is also what? A metal. So therefore, I will say 2, I'm naming from here to here. It is 2, 3. Immediately we have 2 of the metals. This is one important thing. 2 means di. 3 means for the substituent. 2 is di. 3 is tri. 4 is tetra. 5 is pent, in that order. So I have 2 of them, so it becomes what? Di. So dimethyl. Dimethyl what? Methyl, there are 7 carbon atoms, so 2, 3 dimethyl heptane. So that is 2, 3 dimethyl heptane. 2, 3 dimethyl heptane. Now let's name it from this side and see. If I name it from this side, this is 1, 2, 3, 4, 5, 6, 7. So the substituent is on carbon number 5, carbon number 6. So let's take it and see. That is going to give me, or pardon me to write it here. So we're going to have it as carbon number 5. So it is 5, 6, and then we have what? Dimethyl heptane. Now let's check and see which is the correct one. This is 2, 3 dimethyl heptane. This is 5, 6 dimethyl heptane. But remember we said something that the substituent must take the lowest numbering. So if you look at 5, 6 and you look at what 2, 3, it means that 2, 3 is lower than 5, 6. And therefore the correct naming is 2, 3 dimethyl heptane. 2, 3 dimethyl heptane. Let's look at example number 4. Now, before we move to number 4, check. Those of you that are not familiar with this type of structures, remember that these can be the same as this. Remember that there was something like this here. So I can call this C, and there is a C here, and there is a substituent C. There is what? Another C, and there is a substituent there, and there is another C. There is a C here, there is a C there, and there is a C here. So if I do it like this, then we can see that C, let me use a different color for the substituent. So C here, C here. This C, there are 3 what? Hydrogen atoms. So it is what? This. And this C, there are 3 hydrogen atoms that are attached. But this one is having a hydrogen, a hydrogen, a hydrogen. And here there are 1, 2, 3, so there's one more bond. Here we are having 1, 2, 3, so one more bond. Here we have 2 more bonds left. Here 2 more bonds. 2 bonds. 2 here. There are 3 of them. 1 here, 1 here, and 1 there. This structure is the same as this because they are 1, 2, 3, 4, 5, 6, 7. That makes it what? Heptane, which is the what? The longest continuous chain that we have. Thank you very much for watching this video. In our next video, we'll be looking at the alkanes and alkynes. So watch out for the next video. Please subscribe.